Starting salaries of 125 college graduates who have taken a statistics course have a mean of 44,464, and it's approximately normally distributed and has standard deviation of 9295. Using an 85% confidence level, find both of the following: margin of error and confidence interval for the mu. Okay, so sometimes what's not spelled out here, and I think a lot of people get confused, is what do I mean by margin of error and what do I mean by mu? Well, this mu is the population mean, and by population, it means that there's this bigger pool of students where this sample of 125 students are randomly sampled from. So it could be like all the college students of Northeast region, or all the colleges that are in one state, and so on and so on. Okay, you can randomly select students and find those who have taken statistics course. And let's say we've collected 125 college graduates. Then they computed their starting salary. It was 44,464 with some standard deviation 9295. By the way, 125 is greater than 30, so there's no need for t-distribution here. We're strictly going off the normal distribution. And so although it's not really spelled out here, the actual interest is in finding the actual mean value, the mean salary of everybody in the state or everybody in that regional college, because often that's what goes into the reports, right? But unless you track down all the college graduates, which is going to take a lot of time and money, you don't know the true value of mu. Only you have an estimate from this 125 college students sample. Okay, so now let's try to compute the margin of error, whose formula is this one. So this is the margin of error when you're trying to handle the mean. Okay, there's another one for margin of error for population proportion. Please don't confuse the two. You have to know which one to use. Alright, so we're going to use this, and that means we need to first figure out z alpha over 2. Sigma is given. It's the standard deviation 9295. This is really the standard deviation of our sample, but that's okay because 125 is pretty big, so this value would be pretty close to the actual standard deviation of the population. So we're going to use 9295, which is really S sub x to be the approximation for sigma. By the way, this value should be Bessel corrected, and usually if they state it like this without any additional information, that means it's already Bessel corrected. Okay, so this is Bessel corrected standard deviation divided by square root of the sample size, which is 125. So that means we just have to figure out what z alpha over 2 is. So let's try that first. First, the steps for getting z alpha over 2 is like this. First, you have to find the alpha, and that's defined as 1 minus the confidence level. And because the confidence level is 85%, we put 0.85, so that gives you 0.15. Now once you've figured out the alpha level, or the significance level, that's what they call it, then the formula for the z alpha over 2 is given as inverse norm of 1 minus 0.15 divided by 2. And you just have to use the calculator to compute this, so let's do it. Let's clear second vars. You go to the inverse norm, put in 1 minus 0.15, so I'm going to put 1, 5, and then enter, and that gives you 1.43, or 1.44 really. So this gives you 1.44. And now we have pretty much everything we need. We have 1.44. So let's just put that in here to calculate. Be 1.44 times sigma is 9295, and then divided by square root of 125. So that's what we need. Let's put that into the calculator. 144 times 9295, and then divided by square root of 125. And we get, oh, I think I messed up with the, I should have put 1.44, I just put 144, so I have to divide that by 100. No, let's do it again. 1.44 times 9295 divided by square root of 125. Okay, so we get 1197.17. 1197.17. Okay, so that's our margin of error. And now for the confidence interval, well, the true mu, the actual population mean, would be close to the mean value that we have, but it will have some error of this value. So we know that the population mu would be equal to this 44464, but plus or minus 1197.17. When you write this, it really means that the value of mu is somewhere between this value minus 1197.17 and this value plus 1197.17. So let's use the calculator to calculate those two values. So first, 44464 minus 1197.17, and then 44464 plus 1197.17. And the true value is between those two, 43266.83. 43266.83, and then the population mu value would be bigger than this one but less than 45661.17. Okay, so that's the confidence interval for the mu.